Moving on to chapter 6, and we're going to deal with exponents, laws, rules. I believe that this is one of the most important sections. This is a very good, having a strong base in exponents is going to be extremely important for Algebra 1 and Algebra 2. So we don't have things in negative exponents. We don't have such a thing as negative exponents. That's really a notation. It represents items in the denominator. We can look at it in a number of ways if we want to. This is equal to 1 over 5 to the 4th. Since the base of the negative exponent is 5, and that's in the numerator, we would take the reciprocal. So notice it went from the numerator down into the denominator. We notice that the exponent went from -4 to +4. I always like saying that when you change the location, you change the sign. Or if you change the sign of the exponent, you change the location, meaning numerator and denominator. So that'll be up to you on which technique you use. I like that. And it says evaluate the expression, so we're going to have to do 5 to the 4th. We remember that 5 to the 4th is 5 times 5 times 5 times 5, or 25 times 25, which is, I think, 525, 625. I always get that wrong. I always think it's 525. Now, notice we have Chewbacca, and Chewbacca holds on to that negative with the base. So this is going to be equivalent to 1 over the quantity -5 to the 4th. And that is going to be equal to 1 over -5 times -5 times -5 times -5, which again is still 1 over 625. It stayed positive because there were an even number of negatives. So we have two things we're going to have to tackle. Each of the pieces, we'll tackle the numerator and we'll tackle the denominator. So 7 to the -1, well, that's going to put the 7 to the 1st down in the denominator. And then -8 to the 0. Here's the tricky part. The base of that exponent is 8. That negative is outside of it. It is separate. It is separate. 8 to the 0 is going to be equal to 1, and then the negative. So we're going to do this part, 8 to the 0, and then we will do the opposite of 8 to the 0. So if 8 to the 0 is 1, the opposite of that would be -1. And since we moved the 7 down, we have a placeholder for the numerator. So we have 1 over -7. A lot of tricky parts to that. Most students are going to get that wrong. So we'll deal with 8 to the -1. That's going to go 8 to the 1st in the denominator. We have -4 to the 0. This time, the exponent is 0 and the base is -4. So that will be 1. And then we get 1 over 8. So big difference between question number 3 and 4. Same thing, this exponent and its base will move. This negative, the negative outside is not going to move. That stays up in the numerator. And that 2 to the -4 is going to move down. And then we have this exponent and this base is going to move up. So that will move up 3 to the 3rd. And we have -1 times 3 times 3 times 3, which is 27. And 2 to the 4th is 2 times 2 times 2. So we have -27 over 16. Keeping track of this, we're going to deal with 6 to the -2, which is 1 over 6 to the 2nd. We have the quantity of -1 to the -4th. So that's going to be the quantity of negative 1 to the fourth moves up. Negative 1 to the fourth is going to be 1. We have 4 negatives multiplying 1. And 6 to the second is 36. We're left with 1 over 36. 7 to the negative 2, we're going to move that down. 7 to the second. M to the 0 is 1. And then n to the negative 4 will go up into the numerator. So we get n to the fourth over 49. So hopefully we're getting faster with that. Negative 9 to the 0 is 1. J to the negative 1 is going to go down in the denominator. K to the negative fourth is going to go down to the denominator. And 2 to the 0 is going to be 1. So we're left with 1 over j k to the fourth. 5 to the negative 2 goes down into the denominator. W to the 0 is 1. Y to the negative 10 becomes y to the 10th up in the numerator. Change the sign, change the location. It was in the denominator. It's now in the numerator. Y to the 10th over 5 to the second is 25. T to the negative fifth. T to the fifth goes in the denominator. 8 to the negative 2. We're going to flip its location as well as the s to the third. 8 squared is 64. S to the third, t to the fifth. 3 to the negative 2, 3 squared goes in the denominator. A to the negative 1 goes down. 9 to the negative 1 goes up. B to the negative 2 goes up. And C to the 0 is 1. So we have 9b squared, 9a. And now we have to simplify those coefficients. So we get b squared over a as our final answer. So now we have to start simplifying things. 17 is outside by itself. X to the 0 is 1. Y to the negative 8 goes down in the denominator. 4 to the negative 2 goes up. Z to the negative 6 also goes up. So 17 times 1 is 17. 4 to the second is 16. Z to the 6th, y to the 8th. 17 times 16 gives us 272. 272, z to the 6th, y to the 8th. So once we recognize, oh, all right, now we have a power of a power. Power of a power, you know that what? We are going to multiply those exponents. So we get p to the 18th. Write your answer using only positive exponents. So q to the negative 4 times 5, we have a power of a power. Q to the negative 20. Now it says only positive, so we're going to move that down. Q to the 20th. So change the sign, we change the location. Now we are multiplying like bases. So when we multiply like bases, we are going to add their exponents. That's 5 to the negative 4th. We have to only have positive. So we're going to move it to the denominator. And I don't know if we leave it like that or whether we write 1 over 625. Not sure what the answer key says for that, but we'll do both. We have like bases, that's to the 1. And so we have the quantity of negative 4 to the 1 plus negative 2, which equals negative 4 to the negative 1, which equals 1 over negative 4 to the first, which equals negative 1/4, or 1 over negative 4. Let's do this first. Let's do the division, because orders of operations tells me to do division before multiplication. They are equal but left to right, so we will simplify that. That's going to be x to the 7th minus 4 times x to the 2nd. So x to the 7th minus 4 is x to the 3rd times x squared is going to equal x to the 3 plus 2, or x to the 5th. Nice way of showing your steps. we'll do, because this is now a vinculum, we will do the multiplication first, v to the 5th plus 3 over v squared, which gives us v to the 8th over v to the 2nd, which equals v to the 8 minus 2, or v to the 6th. We are going to distribute when we have a power of a power and with multiple things inside. We're going to distribute. We need parentheses to the 3rd, t to the 2nd times 3. So negative 8 to the 3rd, that's going to be negative 8 times negative 8 times negative 8 times negative 8, t to the 6th, and negative 8 to the 3rd is negative 512 t to the 6th. We again, here's a trick one. So there are 3 things inside this parentheses. There's a negative, there's a q to the 4th, and there is a 5. And we have the negative exponent. So we didn't talk about this too much in detail, but if we want to get rid of the negative, we're going to change the sign, change the location, aka also known as taking the reciprocal. So we could see this as 5 over q to the 4th quantity to the 3rd. So we changed from a negative to a positive exponent by flipping, taking the reciprocal. And now we're going to distribute that 3, the power of 3, to all 3 of those pieces. Very important, all 3 of those pieces. All 3 of them. So we technically have negative 1 to the 3rd quantity times 5 to the 3rd over q to the 4 times 3. And that's, we can write it separately like that. That's going to be negative 5 to the 3rd is 125 over q to the 12th. And that would be our answer. We have 3 things again. We have a 1. We have a 3, which is not attached to the h to the 5th. The base of the 5th exponent is just h, not the 3 also. And then, of course, we have that negative. So let's deal with the negative first. We're going to flip it, 3h to the 5th over 1 to the 4th. And so we get 3 to the 4th times h to the 5 times 4 over 1 to the 4th. 3 to the 4th is 81, h to the 20th over 1, which equals 81 h to the 20th. So orders of operations, we're going to do exponents before the multiplication. So we are going to, better yet, let's simplify inside each of these, because we got some like terms here, and we got some like terms in here too. So I'm going to simplify before I do any of those exponents. You have 5, you have x to the negative 4 minus 2, because we're dividing those, times y to the 3rd minus 0 over 2 squared. And I'm going to simplify that. And that's 5x to the negative 6th, y to the 3rd over 2 to the 2nd. And I don't know, I can sort of make that a positive. So we'll do 5y to the 3rd over 2x to the 6th to the 2nd. And now we will distribute that 2. So we have 5 to the 2nd, y to the 3 times 2 over 2 to the 2nd, x to the 6 times 2, which equals 25 y to the 6th, 4 x to the 12th. Well, times. So now we're going to simplify the other right side. So we're going to simplify that. That's 4x y to the 1 minus 3 squared. So that can simplify to 4xy to the negative 2nd squared. And let's get rid of that negative exponent. So that's 4x over y squared to the 2nd. Now let's distribute it out. So that's 4 to the second x to the second over y to the 2 times 2. And we get 16x to the second over y to the fourth. Now let's multiply. Let's put those all in the same place. So we have 25 times 16 times y to the sixth times x to the second over 4 times x to the 12th times y to the fourth. Things in the numerator go in the numerator. Things in the denominator go in the denominator. I'm going to cancel those. So I have 100. And now I have like variables. I have x to the second minus 12 because we're dividing. So we subtract y to the sixth minus 4. And my final answer is going to be 100 x to the negative 10, not my final answer, y to the second. We need only positive exponents. So that negative 10 is going to go down in the denominator, and that should be my final answer. Simplify the expression, write your answers. Okay, same thing. So I'm going to simplify inside first. So 2a to the 0 is 1. We have b to the negative 4 minus 3. And that's all going to be to the fourth. And I'm going to have a to the 3 minus negative 4. And I'm going to have b to the negative 2 minus 4 over 3 to the third. And I'm going to simplify. That's going to be 2b to the negative 7th to the fourth. And this is going to be a to the 7th, b to the negative 6 over 3 to the third. And I'm going to write this as 2 over b to the 7th to the fourth. I'm going to write this as a to the 7th over 3b to the 6th to the third. And now I'm going to distribute it out. Sorry. 2 to the 4th, b to the 7 times 4, a to the 7 times 3 over 3 to the third, b to the 6 times 3. 2 to the 4th, 16, 7 times 4 is 28. A to the, I'm writing so big, 21st over 27. 3 to the third is 27. B to the 18. All right. We have 16a to the 21st over 27b to the 28 plus 18. 16a to the 21st. 27 to the b, 346. Wow, that's crazy. I hope that's right. It feels big, but who knows? It could be. Hopefully it's right. You'll let me know. I love this. This is one of my favorite parts that doesn't get practice. So when we see exponential or scientific notation, we know that we are making big numbers smaller or smaller numbers bigger. And we have it in a format that makes it very, very easy to, number one, write, because we're not writing all these zeros, and we can multiply it. So we're going to multiply their base times their base. So when I have 4.3 times 6, that's going to give me 25.8. And then we're going to multiply their like bases. We're multiplying like bases, so we're going to add their exponents. So this is going to give me 25.8 times 10 to the third. Now I'm not done because scientific notation needs to be between 1 and 0, 1 and 10. So I'm going to move this decimal point over. So that becomes 2.58, and that adds, because it takes place of a 10, it made something bigger, smaller. So where did that bigness go? It went right here. So 2.58 times 10 to the fourth would be my answer. So neat technique. Same thing when we divide. We are going to take their base numbers and divide those, and then we're going to take their powers and subtract those. So if I have 1.2 divided by 4.8, that's going to give me 0.25 times 10 to the negative 3 minus, that's the division, minus negative 10. That's 0.25 times 10 to the negative 3 plus 10. And that is going to give me 0.25 times 10 to the 7th. Now, this number needs to be between 1 and 10. So I'm going to move it. So that made smaller. So where did the smallness? I made a small number bigger. So that means we have to subtract, because negative 10 to the negative 1 is small. So that becomes 2.5 times 10 to the 6th. Very, very tricky there. That's a great question. That's why I put it on there. And without evaluating, rewrite this. So we need a common base with a single power base. So we can see 8 to the 21st. Well, they want us to rewrite 8. Well, 8 as a power of 2 is 2 to the 3rd. So that's the trick there. And 16 to the 18th, well, 16 is 2 to the 4th to the 18th. And 4 to the 11th, 4 is 2 squared to the 11th. So each of those can be rewritten, and then we have a power of a power. 4 times 18, 2 times 2 to the 11th. So this becomes 2 to the 63rd. This becomes 2 to the 72. This becomes 2 to the 22. So we're going to replace each of these with this new power. So where we saw 8 to the 21st, we're going to write 2 to the 63rd. Where we see 16 to the 18th, we're going to write 2 to the 72nd. And where we see 4 to the 11th, we're going to rewrite that as 2 to the 22nd. All of those are equivalent. So it's not like we changed the values, we just changed the base. We rewrote each of the base. So 8 to the 21st, because we can't multiply those. We can't use adding of the exponents because they don't have like bases. Since they don't have like bases, we can't simplify them easily. 4 to the 11th. But now, when we rewrite all this, 2 to the 63rd times 2 to the 72nd over 2 to the 22nd, now they have like bases. So now, because they have like bases, we can combine them. Multiplying, we're going to do 63 plus 72 over 2 to the 22nd, which produces 2 to the 135 over 2 to the 22nd. And now, since they have like bases, we can subtract their exponents. Minus 22 becomes 2 to the, 113? Yeah, I think that's correct. So that would be our final answer. Love it. Some really good problems for you to be practicing. If you have any questions on your homework, hopefully you reached out to this, and this would definitely help explain things. Good luck.